All right, guys, this video is going to cover part two of simplifying radical expressions. This is going to go over a second method. This method typically allows you to work a lot faster and a lot more efficient when it comes to simplifying radicals, right? I do want to be upfront with you. To be able to do this method, you're going to need to do basically two things. You're going to need to have your perfect squares memorized, which I have a list of these off to the right. And you're also going to need to really know your multiplication facts, right? That's the only way you're going to really be able to work with this new method, quickly and easily. So let's just dive right into it so you can see what this looks like. So for you to be able to simplify these radicals or these square roots by this method, the very first thing you want to look at is finding the largest perfect square factor of that given number. So for example, if I want to simplify number 4, we're looking at the square root of 72, right? If I want to simplify the square root of 72, then let's consider, two numbers that multiply to give me 72. And I want one of those numbers to be the largest possible perfect square that fits into 72. So if I look at this list here, okay, I'll give you guys a second to see if you guys can figure out and see which number we're going to be using here. What you'll end up seeing is that the 72 can be broken up into 36 times 2, right? 36 times 2 still gives me 72. But what this allows us to do is basically split up those square roots, right? I can say that this is the exact same thing in red as the square root of 36 times the square root of 2, right? Still the same thing. But now that this is separated, now we can see here that, well, looking at the square root of 36, well, what is the square root of 36? The square root of 36 is 6. So this would give me 6 times the square root of 2. And there is my simplified radical form using this new method. And so, again, got to know your multiplication facts and you have to know your perfect squares, right? But this method is my favorite personally. If it's a number that I can work with, I'm going to do this every single time. If I look at number 5, let's try this one, the square root of 300, right? Going with the same process here. What are two numbers that can multiply to give me 300 where one of them is a perfect square? Specifically, I want it to be the biggest perfect square that fits in a 300. The hundreds are the kind of easy ones because if I look here, well, 100 times 3 would give me 300, right? If we break that up, we got the square root of 100 times the square root of 3, right? And what's the square root of 100? Well, the square root of 100 is just 10. And then we multiply that by the square root of 3. So here is our simplified radical, 10 times the square root of 3, right? I prefer this method versus going over and, doing your branches 2 times 150, 2 times 75. By the time you're done making these branches, we probably already finished by doing it this different method, right? This method does take practice though. So let's do a couple more problems just to kind of give you a general idea of what the mindset for simplifying this method, how it looks. So let's go back to some of the previous problems that we did in the notes. Let's look at the square root of 54, right? The square root of 54, if I want to break this up into two numbers that multiply to give me 54, I'm going to choose the numbers 9 and 6, right? I know that 9 times 6 gives me 54, and well, the square root of 9 is just 3. So this would be 3 times the square root of 6 in simplest form. If I were to do the next one, 2 times the square root of 50, right? These are ones you want to be careful for because you'll notice that there's already a 2 on the outside. So I like to just write the 2 down on the outside so that I don't forget. The 50, we can break it down into two numbers that multiply to give us 50. And we want one of those to be a perfect square. So we can break down the 50 as 25 times 2. 25 times 2 gives me 50. And I know if I look at just the 25, well, the square root of 25 is 5. I had that 2 that was out initially. And what's happening between these two guys is that they're being multiplied. So I have 2 times 5 and then multiplied by square root of 2. If we multiply this out, 2 times 5 is 10. We get 10 root 2 as our answer in simplest form. Now, I do want to show you an instance where this method might not kind of work, and I'm just going to make a number up here. Let's say, for example, that you're asked to find the square root of something like 448, right? At least for me, off the top of my head, I can't think of, what numbers can multiply to give me 448 where one of them is a perfect square. So if it's a number that is going to take you a little while, what I would suggest is just break it down using the factor tree method, right? This method is known as prime factorization. So if I were to break this down, then we're looking at, 448 is an even number. What I told you guys in part one of the video was if it's an even number, you can always break it down by 2, right? So I'm going to break this down by 2. And when I break this down by 2, what I'm essentially doing in my head, if I don't have a calculator, is I'm basically just taking half of 448, which would be half of 448 would give us 224. right? I like to start by, breaking it down by twos because the numbers get smaller and then it becomes more manageable, right? So if I look at 224, then I can do the same thing. 224 is even, so I'm going to break it down by two again. And since two is prime, I'm going to circle that branch. 224, if I take half of that, we get 112. 112, again, I'm going to keep doing the two thing until I get to a number where I'm comfortable with. 112 divided by two would be 56. So we got another prime of 2. 56, well, I know 56, I can do 2 and 28. And I've gotten to the point now where I'm comfortable with the 2 and the 28. I know that, well, I got 7 times 4 would give me 28. 7 is prime, 4 breaks down into 2 times 2, right? So the idea here is you keep going until you get to numbers that you're very comfortable with. And so now I can take a look at actually simplifying this radical, right? If I were to simplify this, I have 2 times 2 times 2 times 2, right? So 1, 2, 3, 4 twos, then a 7, and then 2 more twos. All right, and so now we go through that process. Well, let's look at a pair of the same numbers. That's one pair of 2, so 1, 2 comes out. Here's a second pair of 2, so another 2 comes out. And then lastly, here is another pair of 2s, so another 2 comes out. And all we have left over underneath that square root now is just a 7. All that's left for us to do is just multiply the numbers out in front. If we multiply here, 2 times 2 is 4, times 2 is 8. This would be 8 times the square root of 7. And that would be our answer in simplest form. To be honest, off the top of my head, I wouldn't have known that what this would have actually turned out to be was 64 times 7 if we were to do it that other method, right? So think of this as pretty much your fail-safe. This little factor tree method, this works every single time, right? If you're working with a number that you're not familiar with, it's always advised to do this. All right, but that's part 2 of that